Okay, this is lecture 5 for chapter 1 in chemistry, and what we're going to talk about today is how to do density. And density is a relationship that lets us identify between like the metal that's in this flashlight and the plastic, the different types of plastics that's here, or the different types of metal that are in the keys, or gold or silver, because what I didn't know until I was looking through this section is that everything has its own, everything in the world, every material has its own density, own unique density. So just like we'll have our own unique fingerprints. You know, when you fingerprint somebody, you can't match those fingerprints to anybody except you. When you get the density of something, and I'm sure, and it's much more precise than the density that we have here for gold of, what is it, 19.3 grams per milliliter. I'm sure it goes out many decimal places, and is able to be measured very precisely. But just like fingerprints match only to one person, density matches only to one person. So it was, to one item, to one type of material. And I thought it was really interesting how they used that idea back before they had all of the chemical tests to identify gold. If you had somebody who's trying to pass off something as gold, they would measure the density of the gold. They would calculate the gold, and they'd be able to say, okay, you're faking here, because when we do this very straightforward measurement where we find the relationship between the mass of this object that you're telling me gold is gold and the volume of water that it pushes out of the way, then if the mass is not 19.3 grams per milliliter, then you're trying to snow me and you're busted. So what we've got here is the relationship that shows for density that exists between mass and volume. And even though that little thing looks like a P, it's not a P. It's a Greek letter, and it's pronounced rho, R-H-O, and it's sort of, I've tried really hard to draw it, I can't. So if you just call it rho instead of P, that'll be good. So we're going to have the relationship that exists in density is mass to volume. So what's the basic metric unit of mass? Grams? Okay, so grams is a basic unit of mass, and the basic unit of volume is liters, right? But with mass, it's usually going to be grams per milliliter. But what I wanted you to notice is that we have two totally different things that we're relating together. You know, we've said when we add and when we subtract units, you know, you have to add grams to grams. You can't add grams to centigrams. You certainly can't add grams and milliliters. But this is an example of what they call a derived unit, because it's combining two different ones. And you can say grams per milliliter, just like your speed or rate. That's an example that I just thought of right now of a derived unit that you're already used to working with. Let's say that you drive 300 miles and it takes you, let's not do this, yeah, and you drive 300 miles, and how long does it take you to drive it? It takes you 6 hours to drive it. So the relationship is that in a time of 6 hours, you've been able to travel a distance of 300 miles. So how far, what is your rate? Your rate is 50 miles per hour. And we're not used to riding miles per hour is 50 miles per hour. We just think, you know, it's 50 mph. But we really have two different units here, don't we? We've got distance and we've got time. So that's similar to what you're going to do with rho. So let's do this example. Let's do this example here. Also speaking of density, that big clunk you heard was this big heavy metal flashlight hitting my table here. It's also a very bright flashlight. See, it's heavy as opposed to this marker that I have right here. Plastic marker. It's lighter. You know, we think of it as lightweight, heavyweight, but it's really the density of something is a measure of how closely packed together the little particles inside it are. So the more stuff that you squish into one place, the heavier it is. So that's what that tells you, is without even knowing the actual numerical density, is you know that the density of whatever this metal is greater than the density of this plastic because it's heavy. Okay? So, back to where we were going to. There's this experiment here which would be a really good one to do. We're not going to do it right now. Example 1.8 on page 30. A gold miner has just found a nugget of pure gold. He measures its dimensions and then calculates its volume to be 0.125 liters. Knowing that the density of gold is 19.3 grams per milliliter, calculate the mass of the miner's nugget. Now you might say, well, how in the world do you know? How am I supposed to know that the mass of gold is 19.3 grams per milliliter? They have references out there that you can go and you can find the density of anything. If you would put that, maybe make that book, guys, so you can share it. So all we have to do to begin this is we substitute in the information that we have. So what do we know? Well, we know the mass, the density of the gold is 19.3 grams per milliliter. Is that what it says? Don't let me write something wrong. Grams per milliliter. And he measured, he measures it, and the volume of this nugget is 0.125 liters. So rho is rho what we're trying to find? No, we already know what the density is. We want to know what is the mass. What is the mass of this object? In other words, hang on just a second. In other words, the miner has this lump of what he knows to be gold. And because he knows what its volume is, and because he knows what the density of gold is, he's going to be able to do a mathematical calculation that lets him figure out the mass. So we say, so we're going to solve for m, right? Now, if you think in algebra, you've had equations where you don't even solve for a number, you've got all of these different letters up there. If we're going to solve for m, this is how I would suggest you do this first. Solve for this letter that you're looking for. Okay. So we want to solve for mass. So how would you do this?
M equals rho times volume is what the book says.
Rho times volume, and the way that they did this, couple different ways. If we're going to solve for m, we want to isolate m all by itself. You can cross multiply. This is actually rho over 1. M times 1 is equal to rho times v. So that's how is the most common way to get it. Another way that you could arrive at that is say, okay, if I know that rho is equal to mass over volume, and I need to get rid of that volume, because I don't care about volume. All I care about is mass. Well, what happens if I multiply by v over 1? Then, if I multiply both sides of the equation by v over 1, then you can cancel those V's, and you have mass is equal to VP, V rho. See, I said don't call it P, I'm not going to be able to help it. Rho times volume. So similarly, if they give you rho and mass, and they want you to get volume, then volume would be equal to VP is equal to M, V is going to be M divided by P, but we'll show you that. So the first important step here is to set up your equation, the formula that they give you, so that what they want you to ask is isolated. Like when it says solve for X, when they give you a formula and say find mass, what they're really doing is saying solve for M, which means isolate that variable. Let me make sure I started this. Yep, I did. Okay, so what's the mass? Well, the mass is what we're trying to find. What's rho?
P.
Okay, rho is this P thing, and what's its value?
19.3 grams.
19.3 grams per milliliter. And we want to multiply it by the volume. What volume do we have?
0.125 liters.
0.125 liters. I'm just going to mark that over 1. Now, I'm going to revert, because we're doing unit conversions here. I'm going to put an X in. I don't know if that'll help or not. Now, we've got milliliters here and liters.
You can't convert it. You have to
And
change.
he wants to know the mass.
You have to change the 0.125 liters into milliliters so that you can cancel out the units.
Exactly, because when we're trying to get mass, the measure, the base unit of mass is grams.
Mm-hmm.
So we want to get it all in grams, which means these milliliters have to cancel out. Well, you can't cancel milliliters out because we have liters. So what relationship is there that exists between, we're going to put the milliliters in the numerator.
1,000 milliliters equals 1 liter.
1,000, is this whole thing showing?
Mm-hmm. Yeah.
1,000 milliliters equals 1 liter. Now, there's another way that you could do it. If you wanted to, you could say 0.001 liter is the same as 1 milliliter, and that's using that prefix thing. I like this.
Yeah. So once you convert the 125 and 1,000, it becomes 19.3 grams over 1 times 125 milliliters over 1?
Yes, and I want to step through this for the video. 19.3 grams over 1. Milliliters canceled. Yes. 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 I'm going to add an extra step. Matthew said it becomes 125 milliliters. Over 1. And you did that by multiplying 0.125 times 100. You can string all of these together
1,000.
in your, times 1,000. You can string all of these together with a calculator. You can remember when you multiply by that 1,000 is 10 to the third. You're multiplying. You're moving your decimal.
Got a new message from Carrie.
Hello, Carrie. That you can move your decimal point 3 units to the right. Or you can remember that this says 125 milliliters, because this is 0.125, which is 0.125 thousandths, which is a milliliter. You can immediately go say that's 125 milliliters. And when you multiply that together, what did you get, my dear?
2,412.5 grams.
2,412.5 grams. Now,
Right,
is that what the answer was?
Mm-hmm.
Yes.
The 125 milliliters would just become 125 because the milliliters cancel out.
Yes, because I said mass is in grams, and I left those milliliters up there. Even though I canceled them out here, So you've got to be careful to make sure that when you cancel your units that you actually do this. Because even though I know in my head that mass is like weight, when it's grams, I was getting ready to say 2,412.5 grams per milliliter, which would have been totally wrong. Now, do you know enough yet about the metric system to know what is remarkable about the mass of that chunk of gold?
It's big.
It is honking huge. There are 454 grams in 1 pound. 454 grams per 1 pound. Okay, so somebody go ahead and divide that by 454 and tell me how much that is.
I don't have my calculator.
Yeah, just go ahead and use the calculator.
Rachel's getting it up.
Okay.
I can't see. What was it?
It was right there.
2,412.5.
2,412.5
grams.
Divided by
454 grams in a pound will give us the number of pounds.
5.314.
Is equal to 5.
3 pounds.
Okay, that's about 5 1/3 pounds. 5.314 pounds. Now, how many ounces are there in a pound?
16.
So there are 16 ounces in 1 pound. Whoops, whatever, that's the unit. What is 16 times 5.314?
I'm gonna go get my calculator. I forgot it.
Wait, what am I doing?
5.314 times 16.
85.024.
Okay, so I'm going to round that to 85 ounces. Okay, now there's something that's called a troy ounce. A troy ounce. Now this, I believe, now girls who are maybe watching this, I'm not 100% sure my accuracy here, but I believe that there are 12 troy ounces in 1 pound. So if you have 12 troy ounces in 1 pound, that means that there's a conversion factor of 3/4 to get this down. So if you take 85 ounces times 12 troy ounces are the same as 16 ounces. 12 divided by 16 reduces to 3/4. So now do this multiplication for me. What you're going to essentially do is get about 20, 61, 62, 63 ounces, right?
I don't know. $63.75.
Okay, 63.75 troy ounces of gold. Now, one of the prices of gold that I heard recently was $1,700 per troy ounce. What is 1,700 times 63.75?
100.
700.
1,700. What's on the video? That noise.
$108,375. Wow.
That chunk of gold that miner found in today's market is over $100,000.
Let's go find that chunk of gold.
So That makes the price of gold quite interesting, doesn't it? But that was the first example that we did of density. So let me see how much time I have left on this.
You have about
I
7
have
minutes.
8 minutes, so I have time to do this first on your own problem. First off, did this help? Guys, not this. This was just my rabbit trail that I thought you would find interesting. And you notice that I used unit conversions all over it. But did that help you with how to figure out? Stop it! Did that help you with how to figure the stuff out? Okay. Okay. So the donkey's coming. At least it was the donkey and not me, right? I'm not the donkey. Donkey's got asthma. Okay. This is on your own problem 1.5, 1.15. And this tells us that the density of silver is 10.5 grams per centimeter cubed. Okay? The density of silver, there's no telling what that one's writing, is 10.5 grams per centimeter cubed. If a jeweler, listen carefully on this, if a jeweler makes a silver bracelet out of 0.081 kilograms of silver, what is the bracelet's volume in milliliters? So the bracelet, okay, this is density. And remember that density, or rho, is mass divided by volume. So which one of these initials here, which one of these variables is 10.5 divided by centimeters cubed? The M. Nope. Because it has 2 units. And
volume.
Also the book says the density of silver.
Right. See, I said it.
The density, which would be rho. So this is the density.
Okay.
And also it has that combined, the derived units there. So rho is 10.5 grams per cubic centimeter. A jeweler makes a silver bracelet out of 0.081 kilograms. That's equal to what? That's the amount of the silver, or the weight amount. So this would be M, isn't it? Because it's the mass of the silver. It's how much gravity pulls on it, mass of silver. What is the problem asking for? What is the bracelet's volume in what unit? Is it milliliters or liters?
Milliliters.
Find volume in milliliters. Now, a very specific reason that I went through, and I said, okay, here's this information over here, here's this piece of information over here, here's what we're looking for, and then where in our formula do the pieces of information go? And that's because, and I so remember working in physics years ago and just because I couldn't figure out where the information went to my formula. Yeah.
Do we want to change the kilograms into grams?
Well, first we want to rewrite our our thing. So we're going to solve for volume. Well, I'll come back to that. Yes, we are going to want to do some changing. But here we have this solved for rho. But we want to solve for V. So once again, if you cross multiply, are you guys real comfortable with this idea of cross multiplying? Because as long as you just have one rational expression and another rational expression separated only by an equal sign, the cross products are equal. And that's just really nice to do. So here we can say PV or VP is equal to N. Does that make sense, what I did? Okay.
Not really.
And I said P again. Here's rho. Let me erase this and start clean. here's rho, is equal to mass divided by volume. We don't care about rho. We already know what rho is. Don't care about m. We already know what the mass is. We want to find v. So first I want to solve the formula for what we're looking for. What are we looking for? We're looking for volume. So we're going to solve the formula for v, which means we want to isolate that v all by itself. So let me flip it this way. M divided by v is equal to rho. Is that right? No problem with that? Now, if we want to have v all by itself, how are we going to get rid of that? Now, we can multiply by the reciprocal, but if we I'm sorry?
Times m.
Well, if we do times m, we're going to do m squared. But if you multiply by the reciprocal, because the m's in the numerator, the m needs to be in the denominator.
That's what I mean.
Okay. Times 1 over m. Okay? Your m's cancel, but we have this mess here that has the volume in the denominator is equal to
P over
rho over m.
Just multiply the 1 over v by the reciprocal.
So, yes, we can. What I want to do here, though, is erase this mess and say, see, we're multiplying by the reciprocal, and it will work. But if you don't know this yet, we're going to learn this because cross-multiplying is so helpful. Cross-multiplying. And you begin to learn it multiplying. You begin to learn cross-multiplying when you're showing that two fractions are equivalent. You guys are good enough at fractions that you can look at this and say, yes, I know 2/3 is the same as 6/9. But when you cross-multiply, that means you draw the little x's. You're going across the equal sign. We would say that your catty corner across the street, and I don't know if you kids ever say that anymore, but you cross-multiply. What is 2 times 9? 2 times 9, is that the same as 3 times 6? 18 is equal to 18. And this 2 times 9 here, and the 3 times 6, that's called the cross product. And there's a property that says that if the cross products are the same, if the cross products are equal, then you can change the equation like this, that's a true statement. So, where cross-multiplying comes in here is so much easier than using those reciprocals and manipulating your equation. If you write this as, so I lied about stopping. Would you turn it off, please? We'll get this done now. If you set this up, would you please turn it off? Thank you. Set this up so you can do cross products. V rho is equal to m, right? Do you agree with that?
Yes.
Because we're doing our rho v. What are we interested in? We're interested in volume. We have volume here. We don't need the rho, so what are we going to do to get rid of rho?
Divide by rho.
Divide by rho. We've divided the left side by rho. What do we have to do now?
Divide the right side.
Divide the right side by rho. And then you have v is equal to m over p. So we're going to go...
Rho, mama. Not P.
Yes. V is equal to m over rho. So now, v is equal to m over rho. What is rho? This. Now, I'm not even going to show you that. Volume is equal to mass 0.08 1 kilogram. Okay, that's the mass over, and I'm going to make this really thick on purpose because we have a complex fraction. Mass divided by density.
It's kilograms, Mama, not kilo.
Is it really a kilogram? Okay.
That's what it says up
Kilogram.
there.
Okay. Now, what did we say that density is measured in? It's grams per milliliter, right? But this says centimeters cubed, so what's that mean? There's in the middle of your book, middle of the page, let me find it.
Well, 1 milliliter is equal to centimeter to 1 cubic centimeter.
And that's what we need. So, I'm looking for it. Where is it? Where is it? Where is it? Where is it?
I don't remember.
It must be way further back in the beginning. Okay, page 15 down at the bottom. They have it centered and highlighted. It says 1 cubic centimeter is the same as 1 milliliter. Okay. This is a very important relationship. It's something you will have to know, so commit it to memory now. A cm to the third is a cubic centimeter, so we can just rewrite that. Don't have to show anything.
That's 1 milliliter.
As 10.5 grams per milliliter. Now, volume is the mass divided by the density. What does this say our density is? And this is where just track with me so that you don't lose it. 1.5 grams per milliliter.
Ugh.
Okay? This looks really yucky and gross. What did you learn about division and reciprocals? Dividing by a number is the same as multiplying by the reciprocal. Look at this. This says this quantity divided by this. That's a nasty mess. So instead of dividing, why don't we multiply by the reciprocal? The volume is equal to 0.081 kilograms multiplied by the reciprocal. I lost where I was. The reciprocal, so we have 1 milliliter divided, by 10.5 grams. Okay? Do you see this? This first, actually this has several important things here. I like that little burro. We've solved for volume, which is what we want to find. Are you tracking sort of with me? And then we plug in the values that we have and make a big deal of making that fraction bar really heavy so that you don't get lost with what you're going. So what you have is 0.081 divided by a fraction. You don't want to divide by a fraction. You want to multiply by the reciprocal of whatever that fraction is. Okay? So now we're going to find volume. What are the units of volume that we have here? Milliliters. So we have to get rid of kilograms and grams. So how are we going to do that? We've got to put in a unit multiplier that lets us get rid of kilograms and grams. Yeah, so the kilograms go down here, is that what you said? Kilograms.
I'm not sure what I said.
And grams. Because the way, is that showing, Matt? The whole,
yeah.
Can you read it just fairly? Okay, because we want to be able to have, we've got a kilogram in the numerator, we have to have kilogram in pound. I mean in the denominator, we have grams and grams. So what's the relationship between grams and kilograms that you want to use for the unit multiplier there?
1 kilogram. Oh, well, wait.
You can set it up two different ways. Whichever way you want to use it is fine. Because here, this is how we need our unit conversion factor to be set up.
Yeah,
so
1 kilogram equals 1,000 grams.
Okay, 1 kilogram, and that's what I would do, is equal to But that's not that this is right and the other way is wrong, it's just that I see it better this way. So now, kilograms cancel, grams cancel. What unit are we left with?
Milliliters.
Milliliters. And what are we looking for? We're looking for volume.
Mm-hmm.
So is milliliters, are milliliters a unit for volume? Yes. Well, what if we had canceled everything and we got grams? So I have to go back and say, grams, are they a unit for volume? And say, no, I did something wrong, let me go find it. So, you multiply, you can multiply this all out on your calculator if you want. But if you do sum in your head, you have 81 milliliters, is that right?
Wait.
81 milliliters divided by 10.5? Because we have 0.081.
I got 7.714.
81 divided by 10.5? Well, let's look at our answer and see if that's what we got.
do?
What I did is I went from here
1.15.
to down here. And did we get the answer?
Yeah, it's the same thing, 7.714.
No, it's not.
I don't see 15. Where is it?
It's on page 24.
It's next to the review
yes,
question.
7.7 milliliters.
I don't think you can see that.
I don't think you can either. So when you do that division, it had 7.7 ml. Now I think in their book they left it as what?
I don't know.
They left it as
You can't see the bottom equation.
that one.
Yeah.
Okay.
You can only see half of it.
Okay. Well, what I did was I wrote 81 milliliters divided by 10.5. Divided by 10.5. And then when you did it, you ended up with 7.7 milliliters. The work shows a little bit differently in your book than what we did because we changed from cubic centimeters to millimeters immediately at the beginning because we knew that definition. So that's the end. Turn it off, please, Matt.